Good morning, everyone. I'm sorry to disappoint you. I'm not a Swedish woman that you might expect it to be here on stage today. Anki unfortunately fell ill yesterday, so if you're watching, I hope you're better soon, and I'll do my best to replace her. Now there's nothing on this screen, just to inform you. Okay, well, a lot of the speakers have given, I think, very interesting presentations. So the introduction itself it's really overlapping exactly what you were saying. We are looking at pathogenic pressure in the environment of piglets, and we have found many different ways to fight them. But in the end, it's not only fighting pathogens itself; it's creating an optimal environment for piglets to be able to survive in that environment. And we're not making it very easy for those piglets after weaning to cope with all those pathogenic pressure. And you all know the different stressors that we put piglets into. And for me, when I got my son 3 years ago, and after a couple of months we started weaning him, that is actually when it really kicked in, how complex it actually is. And that's what we try to do in a matter of a couple of days, radical switch from milk to feed, and then we hope that everything goes well. If we look at the effect in the end, and maybe it's in addition to what you have said before, investing in piglets in that first week, make sure that they eat enough, will have a long-lasting effect until the end. So this is a slightly older study where you see that in groups where piglets ate different amounts of feed in that first week, the effect at slaughter age, looking at the weight, is quite significantly. So investing in getting that feed in the first week will make sure that pigs get at a higher weight or earlier at slaughter weight at the end. When you look at an integrated system, this is very easy to apply. If you look at the Northwestern Europe situation primarily, where the link between producing piglets and fattening pigs is quite often not in the hands of one person, this is sometimes a tricky discussion, because who will invest where exactly? So that is something where we might be able to improve. If you look at gut health in general, it's about balancing, and this is a discussion that is changed in the last years. Instead of trying to kill all pathogens that we can find, primarily bacteria, of course, we're now trying to think differently, because we find out that it's impossible to get rid of all pathogens. However well we manage farms, however clean we create the environment, use antibiotics, which is getting more difficult all over the world, and that main balancing tool, antibiotics, is being taken out, and next to follow are components like zinc. So the question is what to do then. And if we look at how we are put together as humans, and for swine it must look quite similar, we can find different stages on where we can try to influence gut health and what is happening on gut level. And with the change to growth promoter free, antibiotic free, beginning of the 90s, we have found some tools, and it has been shown in one of the previous presentations, that working with acidifiers is a great tool to reduce the pathogenic pressure to start with. And that focus, and the circle can even be a bit smaller, I guess, is really on the first part. It's looking at what is happening in that stomach, a lot of acidifying power to stimulate digestion as well, also to make an environment that is less favorable for pathogens. And when you use organic acids as acidifier, you also have the direct killing effect of E. coli and Salmonella, for instance. And we know this for 30 years. It's been used all around the world, starting with citric, formic, and now formic lactic is really what we find in most places as a standard way to acidify pigs. It helps, but it's not enough. You can't block the way for all pathogens to, in the end, have negative effects in the rest of the intestinal tract. So that's a challenge. How do we create tools that have an effect further down the line as well? One of the molecules that more and more researchers and also companies are looking into is how can we use the power of butyric acid. And also this has been mentioned in the lectures before, not by people that are involved in organic acid production as such, but when you work with prebiotics, fibers, probiotics, they all come together because in the end they make sure that the butyric acid production in the animal comes to a higher level. And very interestingly, that butyric acid, where can you find it in nature? Well, in milk. It's quite a vital component of any type of milk, sow milk, cow milk. I've seen a study on camel milk. And so for the very young piglets, that supply of butyric acid is guaranteed by the milk itself, which of course falls away after weaning. And why is butyric acid so interesting? Not in a way that formic acid, acetic acid, propionic acid, or other organic acids are interesting. This is really a director of the whole gut health status inside the gut of, well, all of us actually, all animals. And it's very difficult to say what is it exactly, what is the most vital part in that mode of actions that makes the difference. It's the combination of a lot. Tight junctions were mentioned, where butyric acid plays a very important role in strengthening them. The proliferation of enterocytes have been mentioned. Butyric acid is a key regulator to stimulate that differentiation and maturation. Microflora, we're just touching the surface, but butyric acid is one of the regulators of that flora balance inside the gut. The immune system, it's a regulating molecule when you look at immune states in the gut. We know a lot about that because for human health, talking about diseases like Crohn's disease, a lot of work is put into understanding how butyric acid plays a role there. And we've seen from many papers that it has a reducing effect on symptoms for people with chronic colon diseases. So it's a very diverse picture, and all of them combined make sure that the gut health status in animals is put to a next level. So that's really the aim, to look further. And we try to look at what is happening in the colon, what the microbiota in that colon is doing, is producing, and amongst that is butyric acid, also propionic acid, valeric acid, other types of signaling molecules that have an effect on the gut health status. Now, how to get it there? If we go back into history, butyric acid is known since the 80s, more or less, as a gut health regulator. But it was only until 10, 12 years ago that protected forms of those acids came to market. And that's important because just like with other acids, if you don't protect it, it's primarily taken up on stomach level. So getting effects further down the line is then very difficult. So important is to protect it, and there are different ways to do so. The traditional coating way is one of them, and since a couple of years, more and more the tributylene is used, which is an esterified a glycerol ester of butyric acid, where you don't need an outer coating, but you turn butyric acid into a fat, which looks like this. The inside is the glycerol, and you have 3 places where you can attach butyric acid on. So basically you turn it into a fat, which creates a higher concentrated form of butyric acid. And since it's a fat, it's only digested after the stomach by lipases in the small intestine. It's a very short trial we have done with a big customer comparing, and this is one example. We have done many in different species, and it's interesting to see that regardless of the form, the effects that whatever products you use are the same when you look at the amount of butyric acid that you bring in. So if you take well-protected forms, regardless of if it's salts or esters, if you look at butyric acid level in that product, that is what in the end determines the effect in the animal. There's a couple of things I'd like to add to there. First of all, it's very difficult to predict what the impact is for a specific farm integrator. If you look at performance data, growth, feed conversion ratio, the variation is enormous. And we see that with all additives, actually. So how can you predict what the value is of a certain component in a diet for a customer? If we try to find a common ground here and what explains the differences in percentage improvement on average daily gain or in feed conversion gain, it's pathogenic pressure. It's disease status on a farm. So if you want to know what to use and how much and what you can expect, you need to know the status up front, the health status of a herd. And what we're missing here is specific gut health measurement tools to be able to predict that up front or to say, okay, so this is how bad or how good it is. We can measure specific pathogens, coli, salmonella, or brachyspira. But if we want to generalize it, so how is the gut health here on this farm? What do we measure then? We have actually too much to choose from, and they're all not specific enough. Another topic that's interesting related to protection of organic acids is where do they end up? And we try to understand how, let's say, the importance of the release location of those type of products. And maybe we can even extend that discussion to essential oils, which you can encapsulate, or other types of solutions. Is release location important? We always thought so. This is a very interesting study. It's just one slide of a big paper, combined work from Chinese and US universities, where they have looked at pigs as a model for humans. So they had Crohn's disease in their minds when doing this paper. And they took pigs as a model and they inserted acetic acid rectally to create a colitis. And they succeeded, that's the second group compared to the control, in creating damage on all levels. You can see histological changes, differences in markers related to tight junction expression, inflammation. And what they decided was to use a butyric acid source, in this case tributylene, gave that orally to the pigs to see can we see differences in the disease development. And they did on all those parameters significantly. And I'm sure that that molecule did not end up in the colon of those animals. So what is then that missing link between release site and effect? And there are a lot of interactions that play a role here, but the signaling pathway and the hormonal communication inside the gut, back and forth, plays a very important role here. And that makes that we might need to rethink certain concepts that we use, or how we put products together, and where do we want those molecules to end up. The last slide that I'd like to share with you is a university trial we did in Illinois. It was, let's say, a standard performance trial, normal conditions, healthy animals, no challenge. What is the performance improvement when we use the tributylines? They also looked at diarrhea scoring. And that's an interesting thing, I think, where we see most problems related to diarrhea, not so much in the first week, but in the second and the third week. We have a lot of tools to make sure that they will survive that first week. And then we do see a lot of issues. We can call them chronic or subclinical. The lesions of the diarrhea scores individually had not a lot of real big outliers. But you see that in the second and third week, using gut health optimizing tools like this will have an impact on the severity of diarrhea or on the litter score. So a healthy gut is a key to good performance. I think we all agree on that. And the question is then, what tools do we use to in the end reach that goal? It's the environment is trying to reduce pathogenic pressure in different ways, but in the end we need to do more. And we're now at that point where we need to look more at the inside, how to make that piglet stronger, to fight off whatever pathogenic pressures they encounter in the end. And butyric acid plays a crucial role there. And what is, in all cases, the most efficient way to work with that? Is that directly supplying butyric acid? Is that working with fibers, with probiotics? I can't say. That has never been compiled and looked at what is now the most efficient way. But we're trying to get there. So that is what I wanted to share with you today.
Thank you, Geert.
Thank you very much for this interesting presentation. Well done. Are there any questions from the audience at all? Anybody? I'll just walk to you.
It's only to catch the last slide in the right way. There were days, but it was not written. Is it days after birth or days after weaning?
Sorry, yes. After weaning.
Oh,
You're correct. Yeah.
Thank you. I've got the microphone back here. Is anybody else interested to ask a question? If not, I'm going back on stage. I have 2 questions from the audience for you. The first one that came in, what is the best strategy to produce butyric acid in feed?
To produce it in feed. Okay, yeah. Yeah, that's what I tried to address in the last stage. I mean, the easy answer would be work with tributylene. But I think the honest answer would be we don't exactly know. It has never been put up to the test what works best. And if you would, you choose one specific situation. And that would be too easy to generalize that and to say, well, in general, this solution is always better. And they might also have let's say, an additive effect. That there are differences in the way they work. Working with probiotics is more focused on lactic acid at this stage. So the effects might be slightly different there as well. But it's an interesting question, and I think we should all look further into optimizing and creating a more accurate solution for specific indications. And if I may, crucial for that is that we develop tools to measure gut health in a more general way instead of measuring pathogens or antibodies.
Thank you. Then I have another one from the audience here. Does tributylene replace acidifiers? Does it like formic acid?
No, it's a valid question. No, it does not, because the site of the action is completely different. The acidifiers really work up till the stomach. If you see papers where you see differences in flora composition, for instance, yeah, that's true. That's most likely more an indirect effect. If you reduce the amount of E. coli that enter into the intestinal system, of course that will have an impact on the development of the flora itself. But you won't find formic acid further down the line. So that's the difference.
Thank you very much. Hope you can all join me in thanking Geert for his excellent presentation.